This is Physics 1 course. In this video I'm going to solve a simple harmonic problem. A simple harmonic has an amplitude of 2 meters and cycles 5 times per second. Find its equation of motion. So we start with Newton's second law, F equals ma, and Hooke's law, which says F is minus kx, and therefore these two tell me that m d2x dt2 is equal to minus kx, and therefore let's write time derivatives with dot, x double dot is equal to minus k over m x. Now whenever multiple derivatives of a variable like x is proportional to itself, that means x has a form of e to alpha t, and alpha is unknown. So now we can put this guy into this equation and find alpha. So let's take a time derivative. X dot is equal to alpha e to alpha t, and x double dot is equal to alpha square e to alpha t. Now put all of these into the equation. Alpha square e to alpha t x double dot equals minus k over m e to alpha t instead of x. Now I can cancel the e to alpha t, therefore alpha is equal to plus minus the square root of minus k over m, which is equal to plus minus I, the imaginary number, square root of k over m. Since I have two values for alpha, I should write x with the two values. So therefore x, my answer will be c1, which is a constant, e to 1 of the alpha t, so it's positive I, square root of k over m t, and plus c2 e to the other alpha minus I, square root of k over m t. To determine the two constants, we need to use initial conditions. So I have one condition here, but the other has not been given. So let's assume that x at time 0 is equal to 0. So now if we put the t equals 0 into the equation and put x equals 0, we have c1 plus c2, because at time equals 0 this is 1, this is 1, therefore c2 is minus c1. So let's now put back into x equals c1 e to I, square root of k over m t, minus, because c2 is minus c1, e to minus I, square root of k over m t. Now this is a familiar equation. Let me write the whole thing here. E to I theta, whatever theta is, like this thing, is always equal to cosine theta plus I sine theta. So you have to memorize this if you didn't know. Now putting that into this equation, it becomes 2I sine, the cosines cancel because of the negative, square root of k over m t. So now let's use this other condition. Amplitude means x max. So x max is equal to 2 units of meters, and x from here is equal to 2I c1 sine square root of k over m t. So now x max is when sine is equal to 1, because sine is smaller or equal to 1, larger or equal to -1. So that's the range of sine. So the maximum is 1. So let's put this equal to 1. Therefore, x max is equal to 2I C1, and from the other equation I know it's equal to 2 meters. So therefore 2I C1 is 2 meters, so I can use this into this equation x. So therefore, let me move this down. X equals, instead of 2I C1, I use 2 meters. 2 meters sine of the square root of k over m t. Now I'm going to use this other information that it cycles 5 times per second. So let's go back down. Let's draw the sine equation. So this is x and this is time. So sine is something like this. So it cycles 1 time here and then goes up and come back 2 times. So it's 1 time, 2 times, 3, 4, 5. And it's telling us that this is 1 t is equal to 1 seconds here, and x equal 0 at time equal to 1 second. So x at time equal to 1 seconds is equal to 0 is equal to 2 meters sine of square root of k over m times 1. So this is 0, that means sine is 0. So whenever sine of something, let's say theta, is equal to 0, then theta has to be n pi. And n can be 0, 1 to anything, integer. So 0, n equals 0 is here. This is n equal 1, n equal 2, n equal 3, n equal 4. Let's say n equal 4, n equal 3, n equal 2. So now we can count all the way up to here. Here L will be 5, 6, 7, 8, 9, 10. So n is 10 at this time equal 1. So therefore the square root of k over m is equal to n pi, with n being 10. 10 pi. So now I can write the final equation. X equals 2 meters sine of 10 pi t. And that's it. Thanks for watching. Please subscribe to support my channel. If you have any question or comment, please send me an email at open.physics.project@gmail.com. Thank you.